Okay, so now we are moving on to problem 3. Okay, prepare an amortization schedule for a loan of $42,000 for 5 years. The interest rate is 8% annually. Calculate the total interest of the loan if an agreement on fixed equal annual payments was agreed. A fixed principal payment agreement was agreed for $8,400 annually, and which form of agreement that provide lower total interest and why. Okay, so okay, amortized loan with fixed equal payments. Fixed equal payments means that every year you're going to pay the same amount of money. Okay, the same amount of money, the same amount of money. While amortized loan with fixed principal payment means that the only constant thing is the principal that you are going to pay. Okay, the principal of the loan that you are going to pay. So there is a difference between the fixed equal payments and the fixed principals payment. Okay, so for 5 year, you're going to pay back your loan with the interest rate, right? And the interest rate is already stated in compounded annually, so that basically means that you don't need to find the EAR. Okay, this is the first option, amortized loan with fixed equal payment. For the year 1, you begin with the beginning balance of $42,000, which basically means the amount of the loan that you borrow. Okay, and how do you find how much money you need to pay each year? Okay, you can use this formula of annuity payment. Why? Because this annuity payment allows you to find the cash flow that if it is paid annually for 5 years, given the interest rate, will result in the worthiness of the $42,000. Okay, so you can find cash flows that if you pay in 5 years with the 8% interest rate, will worth 40 will is going to worth $42,000 today. Okay, so you can use the present value of the annuity for the 42,000. Okay, you know that the 42 assume that the 42,000 is the present value. Okay, and then you need to find the C, and you just need to move the C here and the 42,000 there, and then you divide 42,000 with this PV/IVA or present value interest factor, and you find that the C is 10,519.17. Okay, this is the fixed amount of payment that you have to pay each year. Okay, so you just need to write down 10,519.17 here for the payment for each year. Okay, while the interest rate is calculated based on the amount of the beginning balance. So you just need to calculate it with the 8% multiplied by the beginning balance. Okay, multiplied by the beginning balance. And how to find the principal paid is basically the total payments minus the interest rate. Okay, total payments minus the interest rate, and this is the principal that you have to pay, the principal of the loan. And the ending balance is calculated by subtracting the beginning balance with the principal paid. Remember that you have to calculate the ending balance of your loan with the beginning balance minus the principal paid. Why? Because the interest paid is not It's not a subtractor in the if you want to repay the loan. Okay, so you need to find the ending balance by subtracting the beginning balance with the principal paid, not by the total payments. Okay, and you find that the ending balance is 34,840.83. This ending balance in the year 1 will be the beginning balance in the second year. Okay, the total payment is still the same because this is with the fixed equal payment. Okay, and for the interest rate, for the interest you have to pay, okay, you need to calculate this 8% multiplied by this balance, and then you find that the interest you are going to pay is 2,787.27. And how do you find the principal that you have to pay? Is by subtracting the total payment with the interest rate, and you find that the principal paid is 7,731.90. And for the ending balance, okay, it's the same with the year 1. You need to subtract the beginning balance with the principal paid, and you get the amount of 27,108.92. Okay, the ending balance of the year 2 will be the beginning balance of the year 3. Okay, the total payment is still the same. For the interest paid, you just need to multiply 8% with this balance, and you find the interest paid is 2,168.71, and the amount of the principal paid is total payment minus the interest paid. Okay, and for the ending balance, you need to subtract this beginning balance with this principal paid, and you find that the ending balance for year 3 is 18,758.47. This ending balance will be the beginning balance of the year 4. The total payment is still the same. For the interest paid, just like the previous year, 8% multiplied by this balance, and you find the interest paid as much as this. As for the principal paid, you just need to subtract the total payments with the interest paid, and you find the principal that you have to pay is this much. And for the ending balance, you just need to subtract this beginning balance with the principal paid, and you find the ending balance of this, and the ending balance of the year 4 will become the beginning balance of the year 5. Total payment is still the same. Interest paid is this much, and the principal paid is this, and the ending balance is 0. Okay, so in total you're going to have to pay 52,595.86. Okay, in total you have to pay this much from the interest and the principal. Okay, now we move on to the amortized loan with fixed principal payments. In the fixed principal payments, the one that is fixed is the principal paid, but the amount of the payment itself may vary, like this. Okay, like this. So we start with the beginning balance of $42,000. Okay, and the principal that you have to pay is this much. Okay, this is constant. As for the interest paid, it is the same with the previous one. You need to multiply 8% with this beginning balance, and you find the interest paid is 3,360 for the first year, and the total payment is the interest paid plus the principal paid. Okay, so this is this is quite different with the amortized loan with fixed equal payments. The total payment here is found by adding interest paid and principal paid up. Okay, and the total payment is this much. The ending balance is calculated by subtracting the beginning balance and the principal paid, the same with the previous one. So you find the ending balance as much as 33,600. The ending balance of the year 1 will become the beginning balance of year 2. Okay, as for the principal paid is still the same because the principal paid is the same for each year, and the interest paid is just like the previous ones, 8% multiplied by the beginning balance, and you find the interest paid is this much. You find the total payment by summing it up, summing interest paid and summing principal paid up, and you find the total payment 11,000 and 88. The ending balance is found by subtracting the beginning balance with the principal paid. Okay, the ending balance of the year 2 will become the beginning balance of the year 3. Okay, and the interest that you have to pay is 8% multiplied by this beginning balance. Okay, and you find the total payment by adding this up. And for the ending balance is beginning balance minus principal paid. Okay, the beginning balance of the year 3 will become the ending balance of the year 3 will become the beginning balance of year 4, and the interest that you have to pay is still the same. It is in the still in the same mechanism with the previous ones. Okay, 8% multiplied by this beginning balance, and you find the interest that you have to pay is this much. The interest paid and the principal paid altogether will make the total payment. Okay, and you need to find the ending balance by subtracting the beginning balance with the principal paid. Okay, and this ending balance will become the beginning balance of the year 5, and the total payment and the interest that you have to pay is 8% multiplied by this. Okay, and then you find the total payment by adding interest paid and principal paid all together, and you find the total payment of this, and the ending balance is 0. Okay, so the total payment that you have to pay, okay, using the fixed principal payment is 52,080. Okay, 52,080, which can be found either by adding the total payment up, or you can just find it by adding the interest paid and the total interest paid and the total principal paid. Okay, and you find, so from this to amortized loan table, we know that the fixed principal payment will allow you to pay less than if you use the fixed equal payments, right? So equal principal reduction, principal payment will result in the lower payments altogether. Okay, so why does that happen? This is because more principal is repaid early in the loan, which reduces the total interest expense over the life of the loan. Okay, so if you can see here, with the amortized loan with fixed equal payment, the principal paid for each year is less. For the first 3 years is less than the principal paid with the fixed principal payments, right? So this is why the amortized loan with fixed principal payments allow you to pay in the lower amount, because the interest paid that you have to pay in the subsequent years will become lower. Okay, will become lower than if you use the fixed equal payments. So that is why the fixed principal payments yield a lower payment altogether. Okay, and if you are asked which amortized loan that you have to choose, of course you have to choose this one because it will result in the lower total payment. Okay, that is problem 3. Now we are moving on to the problem 4. You are said to be receiving $20,000 per year for the next 5 years. The applicable interest rate is 11% annually. What is the present value if the payment is in the form of ordinary annuity? And what is the present value if the payment is in the form of annuity due? Which gives the highest present value and why? Okay, so this is a type of annuity which is identified by the definite period of time, 5 years, and the constant amount of money that you are going to receive for each period. In this case, $20,000. Okay. The difference between the ordinary annuity and the annuity due is the fact that ordinary annuity is paid at the end of each period. While the annuity due, the first payment is made at the beginning of each period, and it is followed by the subsequent payment. So the second payment will also be paid in the beginning of the period, and so on and so forth. Okay, so the difference between the ordinary annuity and the annuity due: in the ordinary annuity, the first payment will be made at the end of the period, while in the annuity due, the first payment will be made immediately, and after that, the payment will be made at the beginning of the period. Okay, so we need to compare between the ordinary annuity and the annuity due. Okay, we move to the problem 4. Okay, this is the cash flow that you're going to receive for 5 years. 5 years is the period you're going to receive this amount of money, and 11% annually is the interest rate, because the interest rate has been stated in annual basis. You don't need to find the EAR. Okay, for the ordinary annuity, notice that we start with the T of 1. Okay, so because the first payment will be made at the end of the period of each period, so we are not going to receive the first payment immediately. We are going to receive the first payment at the end of the period. So for example, if this is January, then the first payment will be made, for example, in the December or something. Okay, so that is why you need to find the present value itself. Okay, the cash flows, this is the same for the 5 year, and you need to find the present value. Oh, this one you need to find the present value by using the single cash flow formula, but you can use the annuity formula if you would like. It will result in the same thing. Okay, you can either use the annuity formula or the present value of the single cash flow, but in this answer key, we are just going to use the present value of the single cash flow. So for the first year, okay, you need to find the present value. Cash flow divided by 1 plus the interest rate to the power of the T, in this case 1. Okay, and you find the present value is this much. For the second year is the same. Cash flow divided by 1 plus the interest rate to the power of the T. In this case, the T is 2. For the third year, fourth year, and fifth year is all this. You can follow the basic mechanism, and you need to sum this up, and you find the sum of the present value, which is 73,917.94. Okay, while with the annuity due, since the first payment is made immediately, we start with the T of 0. So the cash flow that you are going to receive for the first period is the present value of itself. You don't need to find the present value of the first cash flow. Okay, so because the present value of the cash flow is the cash flow itself, which is 20,000 in this case. For the next period, you just need to divide this cash flow with 1 plus interest rate to the power of 1, and for this present value of the second year of the cash flow. You just need to divide the cash flow with 1 plus the interest rate to the power of 2, and it will result in the 16,232.45. And for the third and the fourth year, is basically the same. You can use the same method, and the sum of the PV is 82,048.91. So um, from this calculation, we know that the annuity due will result in the higher present value. So because this is the case of receiving money, of course the higher present value is more desirable, right? So in this case, the annuity due is more preferable. Why the annuity due results in the higher present value? Because notice that in the first period of receiving the money, the cash flow equals the present value itself. So the present value of the first payment doesn't need to be discounted. So that is why you will have a larger amount of present value using the annuity due rather than the ordinary annuity. Okay, so that's for problem 4. If you want to find this cash flow, the present value of this cash flow using the annuity, you can just use the annuity formula. Okay, basically it will result in the same thing. Okay, so yeah, if you want to try with the annuity formula, yeah, you can just go on and try with the annuity formula. Okay.